Hello, everybody, and welcome to Angular Online. My name is Eva, and I work for this.labs. And hold on 2 seconds, and I'm going to share my screen with you and give you a little overview, and then we'll dive right into talks. So this is the Angular Meetup Online, and I'm Eva Howe, as I said, and our two sponsors today are this.labs. This.labs is a tech consultancy, and we do all things JavaScript and front-end things. So if you need some help with something, please give us a holler. We'd love to help. And our other sponsor is StackBit. Static sites in the Jamstack are growing fast. Front-end devs already get it. It's fast, secure. And as a developer, you get full control over the markup and design. But convincing clients to go static hasn't been quite so easy. How will they update their content? Where is the CMS? The full-on adoption of Jamstack in a commercial context relies largely on solving this issue. This is where our friends from StackBit come in. StackBit is empowering developers to publish a Jamstack site in minutes, use any theme in static site generator, and StackBit handles the CMS integration. You can import your own existing themes from GitHub or choose a pre-built theme in StackBit. StackBit allows you to test the strengths and weaknesses of the popular headless CMS really quickly and explore which one is the right fit for the client or project. Now you can go to our link, stackbit.com/modernweb, which we will include in the notes, and feel the magic and let us know what you think. So our next upcoming events, we have React Online next week, and then the following week we have Review Online. Our two wonderful speakers today are going to be Alex Eagle and Chris Whitehead. And Alex will go first, and then Chris will go next. And in between, they will answer any questions, so please feel free to put those questions in the chat, and they will answer them at the end of the chats. And then I think we're all set. All right, I'm going to stop sharing my screen, Alex, and you can take it away.
Okay, cool. Thanks, Eva.
You're welcome.
Okay, there you go. So I'm going to talk about dynamic bundling on the edge. I should preface this talk with this is the first time I'm going to try and do a talk on this material. I was actually had an interesting meeting at an airport with somebody who works on edge computing, and I learned how similar the problems that I was solving are to what he was doing, and so it made a lot more sense to me. And so I've been looking for a chance to talk about this, but this is kind of a rehearsal, so so bear with me. So So yeah, I'm Alex. I work on the Angular team at Google. There's my GitHub and my Twitter. I'll put those again at the end. And I work primarily on Bazel, which is a build system, and making that work with Angular and also with the rest of the front-end ecosystem. So actually nothing Angular specific about what we're doing with Bazel. Bazel is Google's build system. And we've been using it for, I just hit 11 years at Google. It's been here since before that. I think when I joined, we were just sort of migrating the very last things into Bazel. It is a build system that builds like everything at Google. So front ends, back ends, data sets, like any sources that need to get turned into a program or something that's distributed. With the exception of a couple projects like Chromium and Android open source. And so the first question I often get is, does Bazel replace Webpack? Because if you're probably thinking that Webpack is your current build tool, and so if I'm suggesting Bazel is a great build tool at Google, and then seems like you would have to switch. And the answer is no, it doesn't replace Webpack. Bazel is not a bundler. A bundler, like Webpack actually does a bunch of jobs, including running all of your existing tools, and that's what Bazel can do for you. So things like, first I need to run the TypeScript compiler to turn my TypeScript into JavaScript, and then I send that through Rollup or Webpack. I run my tests with Jasmine, and then I optimize it with Cursor. Usually all of these things are kind of hidden from you because Webpack knows how to do all of the steps, including the bundling and optimization. Under Bazel, we would still have Webpack do the bundling, but we would have the other tools be run like through their own command line interface rather than using plugins to the build tool. Plugins to Webpack, I should say. So one big advantage of that is that it means that every time you like write a new tool, like a new test runner, like Cypress or Jest or a new dev server, today you would have to have a whole plugin ecosystem to do all of the steps of like compile my Sass and transform my stylus and templates and like all the other things that have to happen in the build. So with Bazel, those things can all be separate, and your tool can just take the JavaScript inputs and do the thing that it knows how to do. So it gives you the right layering where all of the different tools can be composed by the user. So this leads us to a question. Okay, so if Bazel is not a bundler and Google uses Bazel, then what bundler does Google use? And the answer is it's not Webpack. First of all, we've been doing this a long time, since before Webpack was developed. So even if Webpack exactly met Google's needs, it would probably still be hard to transition. But let's actually talk about what bundler we do use. So you can run the bundler yourself, and I will attempt to do that right now. So here's my calendar. I've got Chrome DevTools open. I'm filtering just on JS, and then I'm gonna like click somewhere that creates a new calendar, right? So like this is like making a new entry in my calendar, and we see over here a bunch of requests just fired off that go to, I'm not sure if this is visible. This text might be too small, but this goes to some really long URL to fetch JavaScript. And it has like /scs in it and calendar static, and then like k equals something and sm equals something. So you can tell like there's a long map of variables that have been encoded into here. And there's an important one, which is m equals something. I can't put my mouse over it because then this hover goes away. But that's okay, because I've got over here in my slides a copy of what that URL looks like. And so in this case, it's really simple. It's like m equals b is the last thing. But in my calendar example I was just showing, the m equals line was actually tons and tons of stuff. So what does this URL do? The fact that it starts with SCS, this is Google's content service, this is actually going to run the bundler on the fly and return back the JavaScript that I'm asking for in this m bit. So I'm saying I need the module named b. The modules have all been renamed to some short name to make the URLs shorter. And this URL includes a bunch of other information that the bundler needs to know. Okay, so that sounds completely crazy. First of all, how would you make a bundler fast enough to serve like an app like Gmail, where obviously it has latency requirements? Why would you want to do this, even if it could be fast enough? This seems crazy to have the bundler be a runtime step. And then, like, do you want to do this on your app? So I'll start with the first question: how can we make it fast enough? So it's all about edge computing. If you've used Cloudflare, then you may have noticed that they have quite a bit of cool stuff that you can do on the edge. Here's edge computing is basically optimizing internet and web by bringing the computing closer to the source of the data and minimizing long communication distances. If you're a web developer, you already know about edge computing in a sense, because you probably publish your production application to a content delivery network or a CDN. And a CDN is just an edge computing where the computation is take the thing I uploaded and serve it to the user. So super, super simple edge computing you're probably already using it. What Cloudflare and other companies are doing is saying, okay, what if you wanted to have a little bit more behavior right there on the CDN, and you could publish your own code there. So it would do more than just serve exactly the files that you had uploaded. I should also add, like for anybody who's not familiar, a content delivery network means that instead of hosting your app on like one data center or 3 data centers in the world, and then everybody's browser needing to make a long distance connection to fetch the stuff from there, a CDN publishes your files all over the world in many hundreds of locations. And so for most users, your data is already super close to them, and it cuts the latency a lot. So that's something most of us do for our apps. Right, so an edge server is like where your CDN runs. In our case, the software that we want to deploy is the bundler. So we want the bundler to run as custom software that we deploy to the edge network. And then that gives you a really short hop from the user, but it lets you put some behavior there so it doesn't need to talk all the way to your data center. So Cloudflare has this. I think other CDNs are developing a similar kind of thing. So what does it mean to run our bundler in something like Cloudflare? So we don't have very much time. Like the whole reason we're running on a CDN is to cut 100 milliseconds, 200 milliseconds of latency out of the round trip. So it has to be super fast. So first of all the assets that we're serving, they already were minified and optimized. It's not like we're doing a whole Terser run or like reading the AST of all of the JavaScript and finding ways to minify it on the fly. That would be too slow. But the JavaScript is not yet assembled into chunks, meaning it's not yet, it still needs to be assembled. It still needs to be put together so that the request that I just made to like Google Calendar should only return one JavaScript file or resource, and it has a bunch of code in it that came from different ES modules that the developer wrote. And then we use this concat.js format that makes it possible to assemble them on the fly. What is concat.js? It's basically cat. If you come from a Unix background, you've surely run cat before. Cat just says, take all these files and print them. Concat.js is a library. We've written it in Go and in JavaScript, and I think we have one in Java that we use internally, but we've open sourced the ones in Go and Node.js. And we added some smarts around it. It's not really just cat. It also like makes sure that the files get served so that the DevTools tree can still show you all the original sources that were there. And we try to avoid talking to the file system if we don't have to. So we do some clever things like check the M time of the files and not do any additional reads from the file system. This thing is so fast. One time I benchmarked the Go implementation of this, and it served 10,000 JS modules in 30 milliseconds. And by served, I mean bundled them. So like, cool bundler. If all you need to do is smash the files together. But for most of us, smashing the files together doesn't work. What kind of JavaScript can you bundle this way, just by smashing files together with cat? It so happens that we already had one, which is require.js, which is not really in fashion lately in the JavaScript community, but still works, still a good bundler, or sorry, it's a good loader. The format that require.js, you can, it's called AMD. I forget what it stands for. Maybe somebody can put it on the chat. And AMD is also embedded into UMD, which is the universal module definition, which has like that as a component. And you can choose to have your AMD or UMD modules be named, which is to say that the module ID is contained inside the file, right? Where normally JavaScript modules are named by whatever the path to the file is. So there's a link there to require.js's documentation about named modules. And this is what one of those looks like. So the first argument to define here, if that was omitted, if it just started with an array of dependencies, that would be an anonymous module, and then the path to the file would matter. It would define what the module is. But if the first argument to define is a string, like here, then that's the module identifier, and so I don't care what the file name is. And so in this particular case, I can just cat all the files together because I don't need to like wrap them with an IIFE that adds the module name and allows them to all be loaded later and still be able to reference each other correctly. Okay, so yeah, so it sounds like if I were to do all those crazy things, like produce named AMD chunks and run my minifier ahead of time and then upload those to the edge and then have some custom software on the edge that bundles them on the fly, sure, maybe I've convinced you that that's possible, but why would we want to do that? So first of all, why do we bundle it all? Why can't we just serve the application we wrote? So the problem is, like, maybe someday we will be able to do that, but browsers are not yet able to load thousands of individual modules. There's a great blog post, like the cost of small modules, I think, by Nolan Day. Is that right? We could put that in the show notes later. So browsers really only need to, they can only fetch a few files at a time. Like they are actually using separate TCP/IP connections, and it just falls apart when you have to fetch many, many, many files to load a page. So we have to bundle. But why bundle on the edge? Why not just bundle as a build step? So it's all about how efficiently we can deliver just the code the user needs. So when I started working on this, the common chunks plugin in Webpack was the way that you would typically do code splitting. And you would have to choose either to download code that's not needed yet, because like the entry point has dependencies on a bunch of things that we don't need to execute until the user interacts with the application in a certain way. Or we have to download code multiple times because the transitive dependencies of whatever code the user needs to run is included in every chunk that depends on that, and so you download those transitive dependencies multiple times. And really the fundamental observation is that depending on what path the user takes through your application, the ideal set of JavaScript to download for each user interaction changes. It depends on what pages I've already visited tells you which parts of the transitive module graph I've already fetched. So Webpack version 4, now there's a split chunks plugin, which makes this a lot better in that you don't have quite that same trade-off of simply downloading stuff multiple times or downloading stuff you don't need. But there's still, if you look at the documentation for this, a maximum number of parallel requests, which is that same problem that if Webpack makes a whole bunch of chunks, then the user has to download a whole bunch of files to make the page work. And so you can specify, okay, maximum of 3, let's say. If you say maximum of 3, then you're kind of going back to that old problem of it's not going to really be ideal. You're just still going to have code you don't need or download code multiple times because you're artificially limiting how fine-grained the user's request can translate into which modules they need. And on the other side, if you set this maximum number of parallel requests super high, then eventually as your application is complicated and your dependency graph has lots of modules that depend on lots of other modules, you end up going back to serving individual modules again. And it's not bundled. Like you have too many parallel requests, runs into the same problem. So this is kind of a good this is a practical way to do it today, but it still doesn't solve our ideal problem. So what we want to do is the client tells us, and this is like that URL I showed from Gmail. The client says, I want these modules, and it's because I've already got those other modules, I don't need them. And so the client tells us which part of the app they need. And you could choose either to have the client maintain this graph so it knows like what parts are visited already, or the server can maintain it and be stateless, and the client says, these are the things I've already visited, and this is where I'm going now. Give me the JavaScript I don't have yet. And then there's another awesome thing you can do once you're doing bundling on the edge, which is what about experiments? So if you do A/B experiments today, you probably have them as a conditional in your code, and there's some variable that says whether or not they should be enabled, but those are served in your bundle to every user. And so you bloat your application, you spend all this time making it a really small number of kilobytes, and now you're downloading all this code to everybody. And if you have a lot of A/B experiments, then all the combinations of those get downloaded. And then the worst thing is you can never make a secret experiment because somebody's going to peek through your JavaScript, especially if you're Google, and try to find out what you're working on. And so we really want to be able to have the JavaScript served to the user depend on whether that user is enrolled in this experiment or not. So now when we get a request for some JavaScript, it means not only do we want to know what path you've taken through the application, we also want to know which experiments are supposed to be enabled for you. Okay, so that's what we do. We're dynamic bundling on the edge. It's cool. I now work on a team that owns both the Bazel, like the build tooling for Angular, other frameworks, and also the serving for those things. And so now that we're working on both build and serve, it's interesting to think about how we're going to make our dynamic edge bundling thing work for everybody. We would love for all Angular apps to be able to do this. So our custom is very our setup is very custom. We'd like to be able to do it with off-the-shelf tools. I think there are probably some parts that we need to open source because the existing tools don't exist, but we should really try to make them interoperate. And then probably Bazel is the best way for us to make all those different tools interact with each other. But of course, we're not going to make anybody use Bazel. If we have some tools that make this thing possible, you can put them into your own build system, and probably somebody will figure out how to do a lot of this with Webpack. But then the key observation is that you still need something running on the edge that, that takes those things and assembles them on the fly. So, so my team is kind of working on this. This is super speculative, and we may or may not actually end up making this sort of easier for everybody to do. This slide came with the template on HackMD, so I don't know anything about this. And so the wrap up is you have to bundle your JavaScript anyway. If you're bundling offline in a build step, it's inefficient. It's probably practical, but it's not ideal. And so if you're a high requirements app where you really need just the right JavaScript, then you could use a user request to decide what to bundle. You deploy your bundler on the edge, and then you have to upload your modules in a way that you can bundle them super fast. So that's it. There's my links again. And sounds like it's time for some questions.
Yes, most definitely. Can you see the questions, Alex? In the chat?
No. I guess I probably have to switch back to the chat.
I'll read it to you. Alex,
No, I'm there now. Sorry.
Okay.
Okay, so I guess I'll start from, well, I see one question only so far. Could dynamic bundling make it to Angular CLI eventually? Yes, it could in theory. I think there's a lot of moving pieces that have to happen. First of all, we need to make it convenient to do it in open source, even if you're stitching together your own tool chain, because really Angular CLI is just a handy wrapper around whatever the underlying tools can do. So first we need to show this is how you would do it. And then even if Angular CLI, Angular CLI can currently deploy your app. You probably saw in Angular 8.3, there's a new feature, ng deploy. Even ng deploy isn't enough to make this thing work that I just described, because you need to deploy it to a CDN that has this sort of dynamic assembly behavior. So we probably need to, so either you could go with something like Cloudflare and we give you an NPM package that you install on the edge that does the dynamic bundling. I think the better answer is that the ecosystem of CDNs should, if we could publish a standard of how those AMD chunks, or I guess chunks is the wrong word, but how we uploaded all those modules. And if you could just deploy that file to a CDN that knows this behavior, then it could just have this concat.js or some sort of dynamic assembly routine built in, and then you wouldn't have any code to publish. So I mean, in the limit, we really need sort of we need the state of the art in the industry to improve. But certainly there are ways we could release this sooner. I don't know. I think it's a science project. It's speculative. It may or may not ever make it to Angular CLI. And I don't think that everybody needs this either. Like I said, for most people, something like the split chunks plugin in Webpack is practical today. Another question is when would a tool like this be made public? Don't have any timeline. We just our new team is figuring that out still.
Okay, sounds good. Anybody else? All right, Chris, you're up. Thank you, Alex.
Okay. Yeah, thanks, Alex. That was great. Oh, you gotta stop sharing first. Hey, Alex, you gotta stop sharing first. Oh, okay. So my name is Chris Whited. Today I'm going to be doing a little bit of a talk on utilizing GraphQL with an Angular application to understand the power of what GraphQL can bring and how we consume that with Angular, and what that helps us out, how that helps us to build better to scale, small, more capable, more resilient applications. I'm a senior software engineer for this which is where Ava works as well. My Twitter, CM Whited, GitHub is the same. So to start today, one of the things I'm going to do is talk about what is GraphQL. I'm not going to go too deep into this. I'm going to focus mostly on the Angular aspect of it. But GraphQL is a framework it's a spec built by Facebook. And what it allows us to do is it allows us to query our API. It allows us to define what data we want to retrieve from an API. Traditionally under REST, what we have is endpoints that we hit that follow a RESTful pattern. Things like I'm going to get, and I'm going to get by an ID, and I'm going to post to create an object, I'm going to put to update an object, delete, so on and so forth. GraphQL came in because there's a lot of inherent issues with REST that we were trying to aim to solve. Those issues are things like underfetching. In the instance of I want to make a request to an API to get a chunk of data, something like I want to get a user, right? So I'm going to grab my user, and that user, I'm going to say, okay, I'm authenticated. Now I want to grab this user data. So I'm going to make a request to my API, get that back, and that has an ID and an email and a username and a role, right? Well, what if I also want that user's comments on something? And traditional REST, what we'd have to do is make yet another request, go back to the server, go and get those comments. And what we found out is that the interaction when we are making a request from a front-end client that is consuming data from an API over a HTTP wire, the most expensive aspect of that is that communication over the wire, is the handshake, is the communicating to the API and saying, this is who I am, do I have access? The API going, oh, okay, we know who you are, you do have access, let me go and get your data. All right, I've made, what is it, a database connection, or maybe it's a request to another thing, so another HTTP request, whatever it is, and now I'm going to return your data back to you. Here you go, thanks, have a nice day. And then we do that over and over and over and over again. That is where you get a lot of delay, right? Especially if you're thinking maybe it's a slower connection area, maybe it's a bit of a dead zone. So anytime that we had to make any of those requests, that's where a lot of our resource intensity and cost comes from. So with GraphQL, we can then say, instead of that, I want to tell you what I want up front. I'm be very upfront about it. I'm going to say, this is what I'm looking for. This is the data that I need. So it helps to solve the underfetching problem by saying, I do want a user, and I want these fields from the user. I want their ID, their email, their name, and I also want all of their comments, and here's the fields on the comments that I want. The next part being overfetching, the other side of this problem, which is to say maybe our REST implementation says, okay, everybody keeps asking me for a user and for comments. Okay, you're going to get comments all the time. Well, maybe I don't need that. Maybe I just authenticated. Maybe I'm using that to set my session state and setting those kind of pieces of information where I don't need my comments. Well, too bad. Everybody else asked for it. Here you are. Here's your comments. So GraphQL allows us to resolve that same method by saying, all right, I'm going to get a user, and here's only the fields that I want from that. Another problem is the all or nothing approach. So in REST, if I make a call and any aspect of that call fails, unless otherwise specified, then we get an error response, whether that's a 404 or 400 or a 500 response, whatever. With GraphQL, it allows us to make requests and specify fields. And if the request fails, or if the request succeeds except for a field that fails, maybe you don't have authentication to access that field, maybe that field makes another HTTP request to another service outside of the original one, and that call failed, whatever it might be, it allows us to get the successful part of those responses, the fields that we know they returned successfully. And then it also gives us the errors that happen. So we can come in and we can rock that data and go, cool, I see that I got these pieces of data correctly. I got the user ID, the email correctly, but I did not get my comments. The comments hits another service because of microservices, and that call failed. No worries, I still get what I get, and then I can log out that error and look into it. Lastly, one of the other things is batching support. And with GraphQL, it allows us to batch a set of queries that we want to run and return them all at once. Again, kind of helping with the overfetching, underfetching problem. If we know to load our application, we need to make a set of 4 queries. GraphQL allows us to specify that all in one request, again, to get rid of the multiple handshakes so we can get everything all at once. GraphQL is a really, really, really cool framework. Definitely highly recommend looking into it. One of the greatest use cases I've seen for it so far is if you have like a big microservice or nano service architecture, like that layer service mesh, adding a GraphQL middleware layer on top of it that does all the communications, knows where to go on those microservices, and then your app doesn't have to care about it. Your app can just consume data from the GraphQL API, make the requests it needs to make, and then the GraphQL middleware is responsible for going to each of those other things, knowing where there's at. So it's a great way to obfuscate that and create that middleware layer. But today, what we're going to talk about is using GraphQL in an Angular application. So there is a framework out called Apollo. Apollo has a lot of different libraries that support GraphQL. They have libraries both on the backend API side to create, whether it's, you have Node.js and Express and you want to add GraphQL to it, here's a library for that. It's all JavaScript based. But today we're going to talk about the Apollo GraphQL library for Angular. And it does quite a few things for us that I'll show you. First off, it has handy schematic support to add to your project with ng-add instead of doing like a npm or a yarn add or install to add it to your project and then spinning it up on your own. With ng-add, it's very, very easy to say just ng-add apollo-angular, and you get it. Not only does it add all the dependencies that it needs, but it also sets up the GraphQL module that that is going to be used. That it does a few things for us. One is it sets up our URI. It says this is the URI of my GraphQL API where I'm going to consume data from, and it manages that connection. It also creates some defaults for us that we can interact with. Things like, I want all of the data that I retrieve to be stored in memory. So it introduces that caching layer. And then it adds this GraphQL module to our application module. So it's ripper and ready to go. It also has support for authentication. So in the case of I need to authenticate, and now that I am authenticated and I have a token and I've stored into my session as a bearer token, we can then retrieve that token out of storage or wherever it is and add it to each of our then subsequent requests for handling authentication. And like, obviously, it also then has support for queries and mutations and subscriptions, which we'll go over individually. And a recent change that they added, which is really cool, is it also handles local state management without a Redux state management pattern, like NGRX or NGXS. So that was one of the big issues that came out when Apollo and Angular started coming together was, okay, how do I use this and a Redux-like pattern? And originally the answer was, well, you don't really. You use the caching layer, it kind of handles that state management for you. But after some back and forth, they've recently added a state management pattern. And just like you would for any state Redux-like pattern, your application then gets to talk to the state, and then the state using side effects and stuff will communicate to your API. But instead of doing it over Rust, it'll use GraphQL. Super, super cool. Highly recommend you check it out. So first, we're going to talk about queries. In GraphQL, a query is a data structure it is a request to our API that allows us to define what data we want to retrieve. Coming back to, okay, so I want a user, or maybe I want users. Each of those, then knowing that our API defines not only here's the queries that you have access to, but also here's the fields inside of them that you can retrieve, that you can see. Also things like I need, okay, so it's a query, but I need to pass in a property. I need to pass in a param to it that says, I want users, but I only want the first 10, or I want them after this amount, or I only want them that have this email address, right? So GraphQL allows us to define those queries and then the data retrieve. My favorite thing about that is GraphQL at its core is very component-based. It follows a very component-based design principle where you have primitive types, string, number, Boolean, etc. And then you can use that to build more complex types, and then use those complex types to build a query, which is just a complex type. So it's really great to be able to say like, all right, so I have this piece of data that represents a whatever, and now I'm going to include that like a comment. So we have a comment has an ID, which is a number, an integer, and then we have the comment, which is a string, and we can say the ID and the comment are both required. I'm going to use that to build out a comment object, and then I'm going to add comment object as an array onto my user object, right? And we build it up. It's very composable. And GraphQL then allows us to say, like I said earlier, these are the pieces of data I want to need. And when you can define what data you want to retrieve, it makes your app incredibly resilient, because then you're not getting unknown data. There's not things sneaking in, whether or not the API, the API may have changed, doesn't matter. You are telling it, these are the things that I want to retrieve, and I know their data types. The Apollo query framework also has support for fragments, which is a really handy way to define common fields that you want to request. and then you can spread out over those. It also utilizes observables, which is our XJS functionality, which it's not like groundbreaking. I mean, Angular HTTP also allows the use of observables, but so does GraphQL, so does Apollo. So then we can retrieve data, we can query our data, and we get an observable back, and we can watch and we can observe data off of that stream and emit those events as things come in and change to any view components that are reading that data and interacting on it. It also allows for piping, traditional ArcGIS stuff with map and with filter. Oops. What is the back on? Oh, there it is. Etc. One of the things that's also available through the Apollo framework is you can create query service classes. So in Angular, we have a service class that is declared as injectable, that which means it can have dependencies injected into it, and you can interact on those dependencies, do things like I'm going to bring in the HTTP framework, and I'm going to make a REST request, right? So with the Apollo library, we can build a query service class that is declared as injectable. All we have to define, there's a overridable property called document, and that defines your GraphQL query. So what you could do is you could say, I have a class called user query, and it extends from the Apollo framework query, and then it takes a generic of any inputs you want to receive, and then what the output type is, and then you give it your GraphQL query. So you can say, okay, so whenever I inject this into another component, I'm going and I call watch on it. Here's any properties that I need to pass in, our inputs, and here's the expected return type, and it's all typed with TypeScript, and it's super safe. And it allows us, again, it just makes our components more resilient and allows for reusability. So now our applications can inject this service layer into multiple different areas. You don't have to redefine your query. Super powerful. Next, what we have is mutations. In GraphQL world, you have queries and mutations, and the difference being queries, I like to think of as like gets. I'm retrieving data. But when I run a query, I should not manipulate data. There's nothing technically stopping you, but it's just bad practice. If we want to manipulate data or mutate data, we use a mutation. And with GraphQL, a mutation is defined. So in queries, we have types. Mutations will say mutation and then the name of our mutation that we're going to run. Generally, they accept input properties. So that can be anything from primitive types, like a string, like I'm going to add a comment, or they can even be complex types, and we can say my input is a type user, or here, an example would be like login, right? So I'm going to have an authentication input type that defines my email and my password, and I can say email is required, password is required, and my input type of authenticate is also required. And when I build my authenticate mutation and it accepts that as the input type, then it makes our apps, again, more resilient by saying, this is what I know is required. I know that these pieces of data are required before I can submit, right? So it helps to eliminate like data that is never going to succeed because it's not valid from getting all the way into whatever layer in which traditionally it'd be checked. So one of the things about mutations is at the end of it, it still functions just like a query. So we pass in whatever we want as the mutation, and then we define what we want the return type to be. So if I know my return type is a user or a comment or a product or whatever, then I can query it just like I would with a GraphQL query. I say, here it is, and these are the pieces of data I want on my response. Just like the query, it also uses the RxJS observables. We can then observe that that data and interact with it to stream and emit those responses and update our UI. It also comes with a very handy optimistic UI functionality, and what that is if I don't want the UI to have to wait for the response of an action, right? If it's add a comment and I want to immediately see that comment, but I don't want to have to wait for the HTTP round trip to complete, then I can use optimistic UI to say, optimistically, my response should be this. On an optimistic response, I should get this. And then immediately, without any wait, without waiting for the HTTP to occur, I can provide what I want that optimistic response to be, and I can interact on that response while the round trip is completing, and then I can handle the error case and or whatever, or just move on and handle the success case. And just like our queries, we have mutations that can be created as service classes, where we can define the input that we need to pass as properties to our mutation and the return type that we're expecting. Just like query, it just has an overridable property called document that allows us to define our GraphQL mutation and what we expect back. Pretty cool. And then we have subscriptions. Subscriptions is an incredibly powerful thing in GraphQL because it basically, very similar to like a WebSockets, right? It allows our app to consume messages in real time from the API. A good example of this would be if I have an app and I'm authenticated and I'm looking in and I'm going to receive messages because somebody else on my team is creating objects that are going to affect me. With subscriptions, we can instantiate a subscription that says, this is what I want to subscribe to, and here's the shape of that data object that I expect back, just like a GraphQL query. And whenever that other user or end other user or whatever starts up, creating those objects, then the API fires that message, and anywhere where I have that subscription will listen onto it. It uses observables, and I can emit those things, whether that's a toast, or maybe it's a dialogue that pops up, or maybe it's just a badge over my user that says, hey, you have a new message. Then you can look there to consume it and read that message. So it was really interesting to look into this because that was one of the things I was questioning as well, was how do we handle the case of like WebSockets of you're creating an object and it's a really, really big object and it's going to take 10 minutes to complete, but here's a response that is the percentage of how complete it is. Or, hey, one of your coworkers just messaged you, they just got off a phone call and they're going to create an object or send somebody over to you, right? So there's a lot of really cool examples of how to use this that still follow the GraphQL underlying theme of, I still only want to see these pieces of data from the subscription. I know that this is the type that I'm going to retrieve. I know this is the shape of my object that I'm going to be looking at. It allows our components to remain very, very safe, very resilient to those kind of things. And we can also create these service classes and then reuse in any component. Maybe we don't want that at the highest level app component. Maybe we want it at a lower level component to consume those only if I'm looking into a certain section of the app. Okay, so in conclusion, GraphQL is a very, very powerful API building framework. To call out to Wes Grimes, sorry, but it does not function like SQL joins. My bad. Just kidding. But it is an incredibly powerful framework that allows our components to kind of take away that uncertainty, that wonder of what's going to happen when we make a call to an endpoint that we have no control over. We don't really know what we're potentially getting back. But with GraphQL, it helps to solve a lot of these kind of issues. Apollo, not only for Angular, but for Vue, for React, for Vanilla.js, for backend APIs, has a lot of great libraries available for you to easily implement GraphQL and consume data from GraphQL, interact with state management, interact with the caching layer. It's getting better and better and better. So when we use Apollo with Angular, it allows us to create really powerful, scalable, reliable applications. And here's some resources. Anybody have any questions?
Chris, do you see the question in the chat?
Yep.
Okay.
So in that case, Eris, what I would say is, this is something I've touched on a little bit. Yeah, if you're using like .NET REST in the backend and you have no control over that layer, it does become a little more difficult. And that's where this like middleware GraphQL layer comes into play, where you can define a GraphQL middleware that consumes data from those .NET REST APIs that you may have no control over. And then your app can consume from your middleware layer or a little bit of like backend for front end kind of stuff. No, I mean, it would depend. Well, it doesn't have to be Node.js. GraphQL can be written in anything, Go, Python, .NET, Java, Kotlin. AWS has some cool stuff with Amplify and AppSync to create them out of the box for you. Very, very powerful. Generates a lot of the stuff for you using Lambdas. Super cool. So no, Node.js is not required.
Anybody else? Speak now or forever hold your peace. Okay, well, I think we're done then. Oh.
Apollo is just it's a library, it's a framework that has other JavaScript libraries to help make connections for you, right? It's just a library. So it's not a middleware to work with NGRX. It has local state management that introduces a Redux pattern, but it is separate from NGRX. It's just its own library. It'd be like bringing in NGRX. You just add it as a dependency. And it helps to say, because, so at the end of it, like a GraphQL request is still a REST request. It's a post request. And you just like, it defines what you're looking to receive. And so Apollo allows you to like write it using the GraphQL schema definition language, and it interprets that and makes the HTTP request for you. So it's just a helper library to do that work for you. I hope that explained it a little bit better. You could just use the HTTP library if you were so inclined. But the Apollo library is really, really easy to use and really powerful as well.
Okay, that sounds good then. Thank you, everybody, and thank you to our wonderful speakers. Thanks, Alex and Chris. We really appreciate it.
Yeah, thank you.
See you all next time.